What is Linux, and why is it popular in DevOps?
Linux is an open-source operating system kernel created by Linus Torvalds in 1991. It has become the foundation of modern infrastructure for several reasons. Open source, fully customizable with community-driven improvements, stability and security, reliable for production systems with a robust permission model. Modular design, install only what you need, reducing the attack surface and resource usage. Powerful CLI, enables automation through shell scripting and pipelines. Dominates infrastructure, powers most servers, cloud platforms, Docker, and Kubernetes. Distribution variety. Ubuntu, RHEL, Debian, Alpine, and others serve different use cases from lightweight containers to enterprise servers. Resource efficient, supports higher density deployments compared to other operating systems. The extensive tooling ecosystem around Linux covers every aspect of the software development lifecycle, making it the natural choice for DevOps workflows.
What are the fundamental Linux file permissions?
Linux file permissions control access through 3 permission types for 3 user classes, permission types with octal values. Read R=4. View file contents or list directory entries, write W=2. Modify a file or create /delete entries in a directory. Execute X=1. Run a file as a program or enter a directory with
Side.
user classes, owner U. The file's creator, group G. Users in the file's assigned group, others O. Everyone else, permissions are displayed as
RWX.
representing owner, group, and others. For example,
RWXR.
means the owner has full access, 7. Group can read and execute, 5. Others can only read, 4. Special permission bits. SUID, 4xxx. File executes as the file owner, for example.
Password.
SGID, 2xxx. File executes as the group. On directories, new files inherit the group. Sticky bit, 1xxx. Only the file owner can delete files in the directory, for example.
/TMP.
How do you change file permissions in Linux?
File permissions are changed with the
chmod.
command using symbolic or numeric mode. Symbolic mode.
chmod whoop perms.
Who,
Yo.
owners,
J.
groups,
O.
others,
Lay.
all's operation.
Plus.
Add, removes,
Equals.
set exactly, example.
chmod u plus x script sh.
Adds execute for the owner, example.
chmod go w config yaml.
Removes write from group and others, numeric octal. Mode, sum r=4, w=2, x=1 per class.
chmod 755 script sh.
Owner rwx7, group rx5, others rx5.
chmod 600 secret senv.
Owner rw only, no access for anyone else, related commands.
chown user group file.
Change file owner and group.
chgrp group file.
Change group only.
umask 027.
Set default permissions for new files, subtractive mask.
What is the difference between soft link and hard link in Linux?
Hard links and soft links, symbolic links, are 2 ways to reference files. Hard link.
ln source link.
A direct reference to the files inode, same inode number as original. Data persists even if the original file name is deleted, cannot cross file system boundaries. Cannot link to directories to prevent loops. Indistinguishable from the original, both are equal directory entries, soft link.
ln source link.
A points to the path name of another file like a shortcut. Has its own inode, different from the target, can cross file system boundaries, can link to directories. Becomes a dangling link if the target is deleted or moved, Quick check.
ls lie,
Shows inode numbers. Hard links share the same inode, soft links show.
Or-
Pointing to the target path.
What is a process in Linux, and how do you manage processes?
A process is a running instance of a program with its own PID, memory space, and system resources. Viewing processes.
ps aux,
Snapshot of all running processes.
tub,
Slash.
htop,
Interactive, real-time process monitoring.
pgrep name,
Find PID to cast by process name, controlling processes.
kill pid,
Send SIGTERM, graceful shutdown.
kill -9 pid,
Send SIGKILL, force kill, uses last resort.
kill all name,
Kill all processes by name.
control +z,
Suspend foreground process.
bg,
To resume in background.
fg,
To bring back.
command and,
Start a process in the background.
jobs,
List background processes in the current shell, adjusting priority.
nice and 10 command,
Start with lower priority, higher niceness.
renice and -5 ppid,
Change priority of a running process.
What is the difference between a daemon and a regular process?
A daemon is a background process that runs continuously without direct user interaction, typically providing system services. Daemon characteristics. Started at boot time by the init system, systemd. Runs in the background with no controlling terminal. Names often end with D.
sshd, httpd, crond, dockered,
Usually runs with system-level privileges, managed via
system tool start stop status service name,
regular process characteristics, started by a user directly from a shell or GUI. Runs in the foreground with a controlling terminal, runs with the user's privileges. Typically terminates when its task completes or the terminal closes. A regular process can be demonized by detaching from the terminal, but modern practice is to define a systemd unit file and let systemd manage the process lifecycle.
Explain the Linux directory structure and key directories.
Linux follows the File System Hierarchy Standard, FHS.
/,
Root directory, the top of the hierarchy.
/bin,
Essential user commands.
ls, cp, cut, /sbin,
System administration binaries.
yptables, fdisk, /etc,
System-wide configuration files.
/home,
User home directories.
/root,
Root user's home directory.
/var,
Variable data, logs.
/var/log,
Email spool files.
/tmp,
Temporary files cleared on reboot.
/usr,
User-installed programs, libraries, and documentation.
/lib,
Shared libraries needed by.
/bin,
And
/sbin, /opt,
optional / third-party software.
/boot,
Bootloader files, kernel images.
/dev,
Device files, block and character devices.
/proc,
Virtual file system, exposing kernel and process info.
/ziz,
Virtual file system, for kernel device / driver info.
/mnt,
And
/media,
mount points for temporary and removable media, key admin paths.
/var/log,
System logs.
/etc /systemd/system,
Service unit files.
/etc /fstab,
Mount definitions.
What are environment variables, and how do you set them in Linux?
Environment variables are dynamic key-value pairs that affect the behavior of processes and the shell. Viewing variables.
env,
Or,
printenv,
list all environment variables.
echo dollar variable name,
Print a specific variable, setting variables.
vir equals value,
Shell only, not inherited by child processes.
export vir equals value,
Exported to child processes, persistent, add.
export,
Lines 2.
~bash rc,
User, or
/etc/environment,
system-wide, common variables.
pith,
Colon-separated list of directories, search for executables.
home,
Current user's home directory.
user,
Slash,
log ime,
current username.
shell,
Default shell path.
ling,
Slash,
lcall,
locale settings.
editor,
Default text editor, use.
unset vir,
To remove a variable from the current session.
What is SSH, and how do you use it securely?
SSH, Secure Shell, is a cryptographic protocol for secure remote access, command execution, and file transfers over untrusted networks. Basic usage.
SSH user at hostname,
Security best practices. Key-based authentication. Generate keys with.
SSH keygen,
Deploy with.
SSH copy ID,
Disable password authn.
SSH deconfig,
Disable root login set.
permit root login no,
Ind.
/etc/ssh/ssh deconfig,
Change default port. Reduces automated scanning noise. Use.
fail to ban,
Automatically bans IP tickets after repeated failed login attempts. Restrict access. Use.
allow users,
Or,
allow groups,
directives to limit who can SSH in, strong algorithms, disable weak ciphers, and MIC tickets in.
SSH deconfig,
Two-factor authentication. Add MFI via PIM modules like
Google Authenticator,
SSH config.
~/ssh/config,
Simplifies connections with per-host settings for port, user, key file, and proxy jumps.
What is systemd, and how do you manage services with it?
Systemd is the init system and service manager in most modern Linux distributions. It manages system startup, services, logging, and more. Common commands.
system start stop restart service,
Control a service.
system enable disable service,
Toggle auto start at boot.
system status service,
Check service state and recent logs.
journal use service,
View full logs for service. Unit files define service behavior and live in.
/etc/systemd/system/
Admin overrides, or
/usr/lib/systemd/system/.
package defaults. Creating a custom service, write a unit file with
unit,
Eh.
service,
and
install,
sections run.
system daemon reload,
To register it,
system enable now service,
to start and enable in one step, other systemd features, timers, cron-like scheduling via
timer,
unit files, targets, groups of units replacing traditional run levels, journaled, structured, indexed logging with
journal,
How do you schedule tasks in Linux using cron?
cron is a time-based job scheduler that automates recurring tasks. Cron tab format, 5 time fields followed by the command.
code minhourdommondow command,
Example,
02**scripts/backup sh,
runs at 2:00 im daily. Example,
/15 */scripts /health check sh.
Every 15 minutes, management commands.
Cron tab E.
Edit your cron tab.
Cron tab L.
List scheduled jobs.
Cron tab R.
Remove all jobs, shortcuts.
At daily.
At-
At weekly. At monthly. At reboot.
System-wide cron, drop scripts into.
/etc /cron daily /etc /cron hourly
Etc. Alternatives. Anacron ensures jobs run even if the machine was off at the scheduled time. Systemd timers, more flexible scheduling with calendar expressions, logging via journaled, and dependency management. Increasingly preferred over cron on modern systems.
How do you monitor system performance in Linux?
Linux provides a rich set of performance monitoring tools, CPU and load.
/top
/
/top
real-time process and CPU monitoring.
uptime
Load averages 15 minutes.
MP stat
Per CPU statistics, memory.
free edge
Total used free and cached memory.
VM stat
Virtual memory, swap I/O, and CPU stats disk.
DFH
File system space usage.
do sh /path
Directory size.
iostat x
Disk I/O throughput and latency.
liatop
Per process I/O usage, network.
ss tulpen
Listening ports and connections.
iftop
Real-time bandwidth per connection.
nload
Interface throughput, all-in-one.
glances nmon
Or,
dstat
for combined views. For production environments, use monitoring stacks like Prometheus plus Grafana, Datadog, or Nagios for historical metrics, alerting, and dashboards.
What is a package manager and how do you use it?
A package manager automates installing, updating, and removing software, including dependency resolution and integrity verification. Debian/Ubuntu, IPT.
apt updates
Refresh package index.
apt install package
Install.
apt upgrades
Upgrade all packages.
apt remove package
Uninstall keep config.
apt purge
Removes config too.
apt search keyword
Find packages. RHEL/CentOS/Fedora, DNF, formerly YUM.
DNF install package
Install.
DNF updates
Upgrade all packages.
DNF remove package
Uninstall.
DNF search keyword
Find packages, key concepts, repositories, software sources configured.
/etc /apt /sources list d
Or
/etc /yum repos d
GPG signing. Packages are cryptographically signed to verify authenticity. Dependency resolution. The manager automatically installs required libraries.
apt list installed
/
DNF list installed
see what's installed.
What is RIID and what are the common RIID levels?
RIID, redundant array of independent disks, combines multiple physical disks into a logical unit for redundancy, performance, or both. Common levels. RIID 0 striping, data split across disks, maximum performance, 0 redundancy, any disk failure loses everything. RIID 1 mirroring, data duplicated across 2 disks, full redundancy but 50% capacity used for mirrors. RIID 5 striping plus distributed parity, tolerates 1 disk failure, needs minimum 3 disks, good balance of performance, capacity, and redundancy. RIID 6 double parity, tolerates 2 simultaneous disk failures, needs minimum 4 disks, lower write performance than RIID 5. RIID 10, 1 plus 0 mirrored stripes. Combines mirroring and striping, excellent performance and redundancy, requires minimum 4 disks, uses 50% capacity, implementation in Linux. Hardware RIID, managed by a dedicated controller. Transparent to the OS, software RIID, managed by the kernels.
MD.
Driver via.
MDATM.
RIID protects against disk failures, but is not a backup. It doesn't protect against accidental deletion, corruption, or ransomware.
What is LVM and why is it useful?
LVM, Logical Volume Manager, adds a flexible abstraction layer between physical disks and file systems. 3-tier architecture. Physical volumes, PVs, raw disks or partitions initialized with.
PV create.
Volume groups, VGs, pools of storage combining one or more PV-TCS via.
VG create.
Logical volumes, LVs, virtual partitions carved from a VG via.
LV create.
Key benefits: online resizing, grow or shrink volumes without downtime using.
LV extend.
Plus,
Resize 2FS.
Ext4 or
XFS groves.
XFS span multiple disks. A single LV can span across several physical drives. Snapshots create point-in-time copies for backups or testing. Thin provisioning, overcommit storage and allocate on demand. Live migration, move data between physical disks with.
PV move.
While the volume stays mounted, LVM is the standard for flexible storage on Linux servers and is especially valuable in environments where storage needs change frequently.
What is the purpose of /etc/fstab file?
/etc/fstab.
File system table defines how file systems are automatically mounted at boot. Each entry has 6 fields: device identified by,
UUID equals,
preferred for stability, or device path, mount point directory where the file system appears, for example,
/home, /data,
a file system type,
ext4, xfs, btrfs, linfs, swap,
etc. Mount options,
default, no time, row, noxec, nosuid,
etc. Dump flag,
0,
or,
1,
for backup tools rarely used, FSCK order,
0,
skip,
1,
root FS,
2,
other FS, example entry.
code UUID equals ABC 123/data ext4 defaults, no time 02.
Important commands.
Mount A,
Mount all fstab entries not currently mounted.
find
Display current mount tree.
blkid,
Find UUID TCS for devices. Warning: a syntax error in fstab can prevent the system from booting. Always test changes with
Mount A,
before rebooting and use.
fail.
For non-critical mounts,
How do you troubleshoot network connectivity issues in Linux?
network troubleshooting follows a bottom-up, layered approach. 1. Interface status.
IP header,
Check interface state and IP addresses.
IP link,
Verify the interface is UP. 2. Local connectivity.
ping 127.0.0.1,
Verify the network stack is working.
ping gateway IP,
Test LIN connectivity. 3. External connectivity.
ping 8.8.8.8,
Test internet reachability, bypasses DNS. If this works but host names fail, it's a DNS issue. 4. DNS resolution.
ens lookup domain,
Or,
dig domain,
test DNS check.
/etc/resolve conf,
For name server configuration, 5. Routing.
IP routes.
View the routing table.
Trace route.
/
MTR.
Trace the path to a destination, identify where packets drop. 6. Port/service issues.
SS Tulpen.
Check listening ports.
NCZV host port.
Test if a remote port is reachable.
TCP dump IF0 port 80.
Capture and analyze packets. 7. Firewall.
Iptables L end.
Or
NFT list rule set.
review firewall rules.
Journoctal K grep DROP.
Check for dropped packets in logs.
How do you set up and configure a basic firewall in Linux?
Linux offers several firewall tools at different abstraction levels. UFW, Ubuntu/Debian. Simplest interface.
Sudo ufwa default deny incoming.
And
Sudo ufwa default allow outgoing.
And
Sudo ufwa allow SSH.
And
Sudo ufwa allow 443/TCP.
And
Sudo ufwa enable.
Firewalled RHEL/CentOS. Zone-based.
Sudo firewall cmd permanent ad service equals SSH.
And
Sudo firewall cmd permanent ad service equals HTTPS.
And
Sudo firewall cmd reload.
NF tables, modern replacement for iptables, default in most current distros.
NFT add rule inet filter input TCP dport 22 accept.
Configuration in
/etc/nftablesconf.
iptables, legacy but still widely used.
Iptables a INPUTP TCP dport 22 JICC EPT.
And
Iptables a INPUTM state EST IBLISHED RELITED JICC EPT.
And
Iptables PINP UTDROP.
save with
Iptables save /etc/iptables/rules v4.
critical rule. Always allow SSH access before setting a default deny policy to avoid locking yourself out.
What is SE Linux and AppArmor? How do they enhance security?
SE Linux and AppArmor are Linux security modules, LSMs, that implement mandatory access control, MIC, restricting what processes can do even if running as root. SE Linux, Red Hat, CentOS, Fedora, developed by the NSI, uses security contexts.
User role type level.
Policies control access based on type enforcement. Processes of one type can only access resources of allowed types. Modes enforcing blocks violations. Permissive logs only. Disabled tools.
Get enforce. Set enforce. Semonage. Restorken. Audit to allow.
AppArmor, Ubuntu, SUSE Debian. Uses path-based profiles that define what files and capabilities a program can access. Modes enforce blocks violations. Complain logs only. Tools.
All status. All enforce. All complain. All genprof.
Why they matter. Traditional Unix permissions only control who can access a resource. MIC controls what each program can do, so a compromised Apache process can't read.
/etc/shadow.
Even if it runs as a privileged user.
How do you manage user accounts and permissions in Linux?
User management commands.
User-add ms/bin/bash username.
Create user with home dir and shell.
Password username.
Set or change password.
Usermod a G group username.
Add user to a supplementary group.
Usertl R username.
Delete user and their home directory. Group management.
Group add group name.
Create a group.
Groups username.
List a user's groups.
Grouptl group name.
Delete a group, privilege delegation with sudo. Edit with
Vsudo.
Syntax checked editing of.
/ etc. / sudoers.
Grant full access.
Username ILL equals ILL.
Grant specific commands.
Username ILL equals ILL /usr /bin /systemtool restart engine X.
Advanced access control. ICLs, fine-grained permissions beyond owner /group /other.
Setfacle MU, username, RW file.
And
Getfacle file.
password policies.
Change M90, username.
Sets max password age to 90 days, resource limits, configure in.
/ etc. / security / limits conf.
Max open files, processes, etc.
How do you optimize Linux server performance?
Performance optimization targets 4 key subsystems. CPU, identify bottlenecks with.
Tub. HTOP. MP stat.
Adjust process priority with.
Nice.
/
Nice.
Set CPU governor to performance mode for latency-sensitive workloads. Pin critical processes to specific cores with.
Taskset.
Memory, tune.
VM swappiness.
Lower values equals less aggressive swapping. 10 is common for servers. Configure huge pages for memory-intensive workloads, databases, JVMs. Adjust.
VM dirty ratio.
And
VM dirty background ratio.
to control write-back behavior, disk I/O, choose appropriate file systems. XFS for large files, ext4 for general use.
No time.
Mount option to reduce unnecessary metadata writes. Select the write I/O scheduler.
MQ deadline.
For SSDs.
BFQ.
For interactive workloads on HDD to CAS, implement RIID or SSD caching for high-throughput needs. Network. Increase TCP buffer sizes.
Net Core RMM max. Net Core WMM max.
Enable TCP window scaling for high bandwidth links. Configure jumbo frames, MTU 9000. On dedicated networks, apply changes permanently via.
/ etc. / sysctl
And set resource limits in.
/ etc. / security / limits conf.
Always establish performance baselines before tuning and change one parameter at a time.
How do you implement centralized logging in a Linux environment?
Centralized logging collects logs from multiple servers into a single location for analysis, correlation, and compliance. Common architectures. ELK stack, Elasticsearch storage /search, Logstash processing, Kibana visualization, with FileBeat as the log shipper. Grafana Loki, lightweight, label-based log aggregation designed to pair with Grafana dashboards. Graylog combines Elasticsearch and MongoDB with its own web UI. rsyslog forwarding simple setup, client send to.
At log server 514.
TCP, or
At log server 514.
UDP, implementation steps, install the aggregation platform on a central server, deploy log shippers, FileBeat, Fluent, or rsyslog forwarding. On each source. Define parsing rules to extract structured fields from raw logs, build dashboards and configure alerts for critical events, security considerations, encrypt log transport with TLS. Implement log rotation and retention policies to manage storage. Protect the central server. Compromised logs undermine forensic investigations. Consider log signing for tamper detection in regulated environments.
How do you implement backup and recovery strategies for Linux systems?
A solid backup strategy balances RPO, how much data you can afford to lose, and RTO, how fast you need to recover. Backup tools.
Rsync avs delete /source / backup /
Efficient file-level sync with incremental transfers.
tar czf backup tar gz /data.
Compressed archives.
dd if equals slash dev slash sda of equals diskimg bs equals 4m.
Full disk imaging, Ristic/Borg backup, modern, deduplicated, encrypted backup tools, database backups.
pg dump.
Slash,
pg dumpall.
PostgreSQL logical backups.
Miscal dump.
MySQL/Maria DB logical backups. Extra backup, hot physical backups for MySQL without locking. Strategy: 3-2-1 rule, 3 copies on 2 different media types with 1 offsite. Combine full plus incremental backups to reduce storage and backup windows. Schedule via
cron.
or systemd timers, critical practices. Encrypt backups containing sensitive data, test restores regularly. An untested backup is not a backup. Document recovery procedures and keep them accessible during incidents.
How do you secure a Linux server?
Server hardening is a layered approach addressing multiple attack surfaces. Minimize attack surface, install only required packages, remove or disable unused services. Close unnecessary ports, verify with
ss tulpen.
user security, enforce strong passwords with PIM modules.
pam pw quality.
Apply principle of least privilege use.
Sudo.
Instead of root logins, disable root SSH login. Use key-based authentication only, network hardening. Configure a firewall, UFW, firewalled or NF tables to allow only needed traffic. Use:
fail to ban.
to block brute force attempts, change SSH default port and restrict access with
allow users.
mandatory access control, enable SC Linux RHEL or AppArmor Ubuntu. In enforcing mode, patching, and updates, apply security patches promptly. Enable
Unattended upgrades.
Debian/Ubuntu or
DNF automatic.
RHEL. For critical fixes, auditing, and monitoring, enable.
Audit.
For system call auditing, implement file integrity monitoring, IIDE or OSSEC. Centralize logs and set up alerts for suspicious activity. Use secure mount options.
Noksec. Nosuid. Nodev.
On
/TMP.
and similar.
How do you manage kernel parameters and modules in Linux?
Kernel parameters control runtime behavior of the Linux kernel. Viewing and setting parameters.
Sysctl A.
List all parameters.
Systl W netip 4. IP forward equals 1.
Set temporarily, lost on reboot. Permanent, add entries to.
/etc/ sysctl-conf.
Or files in.
/etc/ sysctl-d/.
Apply without reboot.
Sysctl P.
Common tuning parameters.
VM swappiness.
Control swap aggressiveness.
Net core somic scan.
TCP listen backlog size.
FS file max.
System-wide file descriptor limit.
Kernel randomize vspace.
ISLR for security. Kernel modules extend functionality without recompilation.
Else mod.
List loaded modules.
Modinfo module name.
Show module details.
Modprobe module name.
Load a module with dependencies.
rmmod module name.
Unload a module, persistence, auto-load at boot. Add module names to.
/etc/ modules.
Or files in.
/etc/ modules load d/.
Blacklist, add.
Blacklist module name.
To a file in.
/etc/ modprobe d/.
Module parameters.
Options module name param equals value.
In.
/etc/ modprobe d/.
How do you troubleshoot high CPU, memory, or disk I/O usage in Linux?
High CPU.
Tub.
Slash.
H top.
Identify the process consuming CPU. Sort by.
Percent CPU.
And
PS aux sort equals percent CPU head.
list top CPU consumers.
Perf top.
Kernel-level profiling to find hot functions. Remediation. Optimize the application. Adjust.
Nice.
Values. Set CPU limits via cgroups. High memory.
Free edge.
Check total, used, available, and swap usage.
PS aux sort equals percent mem head.
Identify memory-hungry processes.
VM stat 1.
Watch swap and slash out activity. High.
Say.
Slash
So.
equals memory pressure.
Smem.
Show proportional set size, true memory per process. Remediation. Fix memory leaks, increase swap, add RIM or set.
Memory max.
Via cgroups, high disk I/O.
IStat x1.
Per device I/O stats, watch.
Percent util.
And
Await.
the
Liatop.
identify which processes are causing I/O.
Df och.
Slash
Do sh slash path.
check for full file systems, remediation. Optimize queries slash writes, add faster storage, adjust I/O scheduler, or spread I/O across disks with RIID, holistic view.
Glances. Nmon.
Or
Dstat.
monitor CPU, memory, disk, and network simultaneously.
What is load balancing, and how do you implement it in Linux?
Load balancing distributes traffic across multiple servers to improve reliability, performance, and availability. Layer 7, application level. HA proxy, high performance, feature rich, configure,
Front end.
listener, and
Backend.
server pool, in.
Slash etc. slash haproxy slash haproxy cfg.
Nginx uses the
Upstream.
directive to define server pools, supports HTTP, gRPC, and WebSocket, layer 4, transport level. LVS, Linux Virtual Server, kernel-level IPVS module, highest throughput, managed via
Ipvasatum.
load balancing algorithms, round-robin, equal distribution, least connections, routes to the server with fewest active connections. Weighted accounts for servers with different capacities, IP hash, session persistence by client IP, high availability for the load balancer itself. Use keepalived with VRRP to manage a floating VIP between active/backup load balancers. Health checks automatically remove failed backends from the pool.
What is containerization, and how do you use containers in Linux?
Containerization packages an application with all its dependencies into an isolated, portable unit that shares the host OS kernel. Docker, the most widely used container platform.
Docker build tmyep.
Build an image from a Docker file.
Docker run dp8080 80myep.
Run a container in the background.
Docker ps.
List running containers.
Docker logs container ID.
View container output. Podman, a daemonless, rootless alternative to Docker. CLI compatible with Docker, drop-in replacement. No central daemon, each container runs as a child process, better suited for rootless and system-de-integrated workflows. Orchestration for production multi-container deployments. Kubernetes, industry standard for scaling, self-healing, rolling updates, and service discovery. Docker Compose simpler multi-container orchestration for development. Security best practices. Use minimal base images, Alpine distroless. Run as a non-root user inside the container. Scan images for vulnerabilities, Trivy, gripe. Set resource limits.
Memory. ZBus.
How do you implement configuration management in Linux environments?
Configuration management automates and enforces consistent system configuration across fleets of servers. Popular tools. Ansible agentless SSH-based. YAML playbooks push model, easiest to adopt. Puppet agent-based, its own DSL pull model, strong ecosystem. Chef agent-based, Ruby-based pull model, Salt Stack, agent-based, event-driven, fast at scale. Ansible example workflow, define target hosts in an inventory file. Write playbooks YAML, declaring the desired state, execute.
Ansible playbook I inventory playbook YAML.
Organize reusable logic into roles, best practices. Version control all configuration code, Git. Use environment-specific variables, dev, staging, prod. Test in staging before applying to production. Apply the principle of idempotency. Running a playbook twice produces the same result. Implement drift detection. Alert when systems deviate from the declared state.
What is systemd networked, and how do you configure networking with it?
Systemd networked is a system daemon for managing network configuration on systemd-based distributions, replacing legacy.
/etc/network/interfaces.
Scripts enable it.
Code systemd enable now systemd networked, systemd enable now systemd resolved.
Configuration files live in.
/etc/systemd/network/. Network.
Files, configure interfaces, IP, gateway, DNS.
NetDev.
Files define virtual devices, bridges, VLINs, bonds. Static IP example.
/etc/systemd/network/10eth0 network. Code match name equals eth0 network. Address equals 192.168.1.100/24. Gateway equals 192.168.1.1. DNS equals 8.8.8.8.
DHCP example.
Code match name equals eth0 network. DHCP equals yes.
After changes.
Systemd restart systemd networked.
Advantages over legacy tools. Declarative config, predictable interface naming, built-in DHCP client, and tight integration with the rest of systemd.
What are Linux namespaces, and how are they used?
Linux namespaces are a kernel feature that isolates system resources for processes, forming the foundation of container technologies. Namespace types. PID process isolation. PID1 inside the namespace is not PID1 on the host. NET, separate network stack, interfaces, routes, firewall rules. MNT, independent file system mount points. UTS, isolated host name and domain name. IPC, separate shared memory, semaphores, message queues. USER, map UIDs/GIDs, allows root inside namespace without root on host. CGROUP, isolated view of cgroup hierarchy. TIME, independent system clocks, kernel 5.6+. Working with namespaces.
Unshare net PID fork bash.
Launch a shell in new network and PID namespaces.
Ncenter TPIDN.
Enter the network namespace of a running process.
LSNS.
List all namespaces on the system. Docker, Podman, and LXC all use namespaces combined with cgroups for resource limits, and seccomp for syscall filtering to create isolated containers.
How do you implement disk encryption in Linux?
Disk encryption protects data at rest against unauthorized physical access. Full disk/partition encryption with LUKS.
Cryptsetup lux format /dev/sdb1.
Initialize an encrypted partition.
Cryptsetup open /dev/sdb1 cryptdata.
Unlock and map to.
/dev/mapper/cryptdata. mkfsx4/dev/mapper/cryptdata.
Create a file system on the encrypted volume.
Mount /dev/mapper/cryptdata/data.
Mount as usual, auto mount at boot. Add an entry to.
/etc/cryptub.
Maps encrypted device to a name. Add the corresponding mount to.
/etc/fstab.
Directory-level encryption. fscript native kernel-level file system encryption for ext4 and f2fs, preferred over the deprecated encrypts. Encrypt individual directories without encrypting the entire partition. File-level encryption.
GPG-C file.
Symmetric encryption of individual files. Age, modern, simple file encryption tool. Key management. LUKS supports multiple key slots. Add backup keys with.
Cryptsetup lux add key.
Backup the LUKS header.
Cryptsetup lux header backup.
Consider TPM, or hardware security modules, for automated unlocking in servers.
What is systemd journaled, and how do you use it for system logging?
Systemd journaled collects and stores logs in a structured, indexed binary format, replacing plain text syslog in many setups. Querying logs with.
Journalctal. Journalctal U engine X.
Logs for a specific service.
Journalctal B.
Current boot only.
B-1.
For previous boot.
Journalctal P air.
Filter by priority. Emerg, alert, crit, error, warning, notice, info, debug.
Journalctal since 1 hour ago.
Time-based filtering.
Journalctal F.
Follow new entries in real time.
Journalctal O JSON pretty.
Output in structured JSON, persistent storage. By default, logs may be stored only in memory.
/run/log/journal/.
Create.
/var/log/journal/.
For persistence across reboots, configuration.
/etc/systemd/journaled-conf. Storage equals persistent.
Force persistent logging.
System max use equals 500M.
Cap total journal size.
Max retention sec equals 1 month.
Auto-delete old entries. Integration. Journaled can forward to traditional syslog daemons.
rsyslog. Syslog ng.
For compatibility with existing log pipelines.
How do you manage system time and NTP in Linux?
Accurate time synchronization is critical for log correlation, authentication, Kerberos, TLS certificates, and distributed systems. Check and configure time.
Timedactyl status.
View current time, time zone, and NTP sync status.
Timedactyl set time zone America/New York.
Set time zone.
Timedactyl set NTP true.
Enable NTP synchronization, NTP implementations. Systemd time synced, lightweight SNTP client, sufficient for most systems. Configured in.
/etc/systemd/timesync-conf.
Crony, more capable NTP client/server. Handles intermittent connectivity and fast synchronization well. Install.
apt install crony.
Or
DNF install crony.
config.
/etc/crony/cronyconf.
Monitor.
Chronic tracking.
Sync status.
Chronic sources.
Server list. Best practices. Use at least 3 to 4 NTP sources for redundancy and accuracy. In isolated networks, set up an internal NTP server hierarchy. Monitor sync offset. Drift beyond a few milliseconds may indicate issues. For precision-critical systems, finance, telecom, consider PTP, Precision Time Protocol, or GPS-disciplined clocks.
What is Linux resource management with C groups?
Control groups, C groups, limit, account for, and isolate resource usage of process groups. Modern systems use C groups v2, managed through systemd, controllable resources. CPU, limit usage or pin to specific cores, memory, cap total usage and swap, disk I/O, throttle read/write bandwidth, PIDs, limit number of processes. Setting limits via systemd.
System tool set property myService CPU quota equals 200%.
Limit to 2 CPU cores.
System tool set property myService memory max equals 1 G.
Hard memory cap.
System tool set property myService IO write bandwidth max equals /dev/SDA 50M.
Throttle I/O, persistent limits, add directives to the services unit file under.
Service.
Eh.
Code CPU quota equals 200%, memory max equals 1 G, memory swap max equals 0.
Monitoring.
System DCGLS.
Display the C group hierarchy.
System DCG top.
Real-time resource usage per C group in containers, Docker,
Memory.
Eh.
ZBus.
and Kubernetes resource requests/limits. Use C groups under the hood. C groups prevent resource starvation in multi-tenant and containerized environments.
What is Linux Traffic Control (TC), and how is it used?
Traffic Control (TC) is a kernel framework for managing network traffic through CO-S policies, traffic shaping, and bandwidth allocation. Core concepts: queuing disciplines, queue disks, control how packets are queued and dequeued, classes subdivide queue disks to create hierarchical bandwidth allocation. Filters classify packets into classes based on IP, port, or other criteria. Common use cases: bandwidth limiting.
Code TCQ disk add dev eth0 root TBF rate 10 mbit burst 32 kbit latency 400 ms.
Prioritizing traffic with HTB, hierarchical token bucket. Create classes for different traffic types. For example, SSH high priority, bulk downloads low priority. Assign bandwidth guarantees and ceilings per class. Buffer bloat mitigation with codel or fqcodel.
Code TCQ disk replace dev eth0 root fqcodel.
Network simulation, useful for testing. Add latency.
TCQ disk add dev eth0 root netum delay 100 ms.
Simulate packet loss.
TCQ disk add dev eth0 root netum loss 5%.
TC is essential for WIN optimization, ensuring critical services get priority, and testing application behavior under degraded network conditions.
How do you implement Linux network bonding and teaming?
Network bonding combines multiple physical NICTCs into a single logical interface for increased bandwidth, redundancy, or both. Bonding, traditional kernel level. Install.
apt install slave.
Or
DNF install network manager team.
common modes, Mode 1 active backup. Only one NIC active, failover on link failure, no switch config needed. Mode 4, 802.3 add/LICP. Link aggregation for bandwidth plus redundancy, requires switch support. Mode 6, balance alb. Adaptive load balancing without switch configuration. Verify.
cat/proc/net/bonding/bond 0.
Network manager configuration, modern approach.
Code nmclicon add type bond if name bond 0 mode active backup. nmclicon add type Ethernet if name eth0 master bond 0. nmclicon add type Ethernet if name eth1 master bond 0.
Network teaming was introduced in RHEL7 as a user space alternative with the
Team day.
daemon and runner types like
Active cup.
and.
LAGP.
However, teaming is deprecated in RHEL9 plus in favor of kernel bonding, so bonding is the recommended approach for new deployments. Important, modes involving link aggregation, LICP, require matching configuration on the network switch. Verify traffic distribution with
IPS link show.
How do you configure and troubleshoot Iptable's firewall?
Iptables is the traditional Linux packet filtering framework, while NFTables is the modern replacement, default in Debian 11+, RHEL8+. Iptables remains widely deployed. Architecture. Tables.
filter,
Default.
nut, mangle, rug,
Chains.
input,
Incoming.
output,
Outgoings.
forwirds,
Routed. Rules are evaluated top to bottom. First match wins. Basic firewall setup.
code iptables pinputdrop, iptables pforwirdddrop, iptables poutputiccpt, iptables input iptables input state est est iblished relitedjiccept, iptables inputp tcp dport 22 jiccept,
Troubleshooting.
iptables lvn,
List rules with packet counters and numeric output.
iptables lvn line numbers,
Show rule numbers for targeted deletion. Add a log rule before drop.
iptables iinput1 jlog log prefix iptdrop,
To see what's being blocked,
iptables f,
flush all rules temporarily to test. If the firewall is the issue, persistence.
iptables save / etc / iptables / rules v4,
Save current rules.
iptables restore / etc / iptables / rules v4,
Restore, install.
net filter persistent,
To auto-restore on boot, migration note. For new setups, prefer.
nf tables,
Which provides a unified syntax, better performance, and atomic rule updates.
How do you implement and manage SE Linux policies?
SE Linux enforces mandatory access control through security policies that define fine-grained permissions via type enforcement. Key concepts, security contexts.
user role type level,
The type is most commonly managed. Policy types.
targeted,
Default confines specific daemons.
strict, MLS,
Modes.
enforcing, permissive, disabled,
Set in.
/ etc / selinux / config,
Day-to-day management.
zestaru,
Check current mode and policy.
lsz file,
/
psz,
View security contexts on files and processes.
semanage fcontext a t httpd syscontent t / var / www / html ***.
Set expected context for a path.
Restorecan rv / var / www /html.
Apply the expected contexts.
Semanage port a t http port p tcp 8080.
Allow a service to bind to a non-standard port. Troubleshooting denials.
Search mivc recent.
Find recent denial messages.
Sealer to / var / log / audit log.
Human-readable analysis requires.
Set troubleshoot.
Bleh.
Audit 2 allow a m policy.
Generate a custom policy module from denials.
Semajule I policy pp.
Install the module, best practices. Never disable SE Linux globally, use.
Permissive.
Mode for troubleshooting. Test custom policies thoroughly before enforcing, use.
Semanage boolean L.
To discover pre-built toggles before writing custom modules, review.
Audit 2 allow.
Output carefully. Blindly applying it may overpermit.
How do you manage and monitor system logs effectively?
Effective log management combines proper configuration, rotation, analysis, and monitoring. Log sources, journaled structured binary logs, query with.
Journalctal.
rsyslog / syslog-ng, traditional text-based logging to.
/var / log /.
Application logs written to custom paths or stdout for containers. Log rotation prevents logs from filling the disk. Configure.
Log rotate.
Via.
slash etc slash log rotate d slash.
Rotate by size or time, compress old logs, set retention, journaled, set.
System max use.
And
Max retention sec.
in
Slash etc slash systemd slash journaled conf.
monitoring and alerting, logwatch, daily email summaries of notable events, fail to ban, detects and responds to patterns like brute force login attempts. Centralized solutions, ELK Loki Graylog, enable cross-system correlation and dashboards, centralized shipping, rsyslog forwarding.
ATAT log server 514.
TCP with TLS. Filebeat/Fluent/Promtail as dedicated log shippers, best practices, use consistent timestamps, UTC preferred, across all systems. Set proper permissions on log files.
640.
Or tighter, archive security-critical logs to immutable storage, establish baseline patterns to identify anomalies. Regularly verify that logging works, especially for security-critical events.
How do you implement disk quotas in Linux?
Disk quotas limit how much storage individual users or groups can consume, preventing any single user from monopolizing disk space. Setup steps. 1. Enable quotas in fstab, add.
USA quota grp quota.
To mount options in.
Slash etc slash fstab.
Remount.
Mount o remount slash file system.
2. Initialize quota database.
Apt install quota.
If not installed,
Quota check comes slash file system.
creates
A quota user.
and
A quota group.
for XFS use.
XFS quota.
Commands instead, quotas are enabled differently. 3. Enable enforcement.
Quatown ev.
4. Set limits.
Add quota username.
Opens editor to set. Soft limit, warning threshold. User can exceed temporarily. Hard limit, absolute maximum. Writes are blocked beyond this. Grace period, time allowed above soft limit before it becomes hard.
Add quota g group name.
Set group quotas.
Add quota p template user user.
Copy quota settings between users. Monitoring.
Rup quota a's.
System-wide quota report.
Quota username.
Individual users' usage and limits. Integrate quota assignment into user provisioning workflows, scripts, or Ansible to ensure consistency.
How do you implement and manage RIID in Linux?
Linux software RIID uses the kernels.
MD.
Multiple device, driver managed via.
MDATM.
Creating an array, RIID5 example.
Code mdatum create slash dev slash md0 level equals 5 RAID devices equals 3 slash dev slash sda1 slash dev slash sdb1 slash dev slash sdc1 mkfsx 4 slash dev slash md0 mount slash dev slash md0 slash data.
Making it persistent.
Code mdatum detail scan slash etc slash mdatum conf update to nitramps u
Add
slash dev slash md0
2
slash etc slash fstab
for auto mount at boot, monitoring.
cat slash proc slash mdstat
Real-time array status and rebuild progress.
mdatum detail slash dev slash md0
Detailed array information, configure email alerts, set.
miilIDDR
In
mdatum conf
and enable the monitoring daemon, use.
smartl
Smart Mon tools to monitor underlying disk health, replacing a failed disk.
code mdatum slash dev slash md0 fail slash dev slash sdb1 remove slash dev slash sdb1 hash physically replace the drive partition identically mdatum slash dev slash md0 add slash dev slash sdb1
The array rebuilds automatically. Monitor with
cat slash proc slash mdstat
maintenance, periodic scrubbing.
Echo check /sys/block/md0/md/sync action.
To detect silent data corruption, always pair RIID with a backup strategy. RIID protects against disk failure, not data loss.
How do you manage and troubleshoot systemd services?
Service management.
System tool start, stop, restart, reload service.
Control service state.
System tool enable, disable service.
Toggle auto start at boot.
System tool status service.
State PID, recent logs and resource usage.
System tool list units failed.
Find all failed units, troubleshooting a failed service. 1. Check status and logs.
System tool status service.
Quick overview with exit code.
Journal tool use service N50 no pager.
Last 50 log lines.
Journal tool use service P error.
Error level messages only 2. Validate the unit file.
Systemd analyze verify /etc/systemd/system/myservice service.
Syntax check.
System tool show service.
Dump all properties.
System tool list dependencies service.
View dependency tree. 3. Common causes of failure, wrong.
Exec start.
Path or missing executable, permission issues, wrong user, SC Linux denials. Missing dependencies or incorrect.
After equals.
/
Requires equals.
Directives, resource exhaustion, check with.
Systemd top.
Customizing services without modifying package files.
System tool edit service.
Creates a drop-in override in.
/etc/systemd/system/serviced/.
After any unit file change.
System tool daemon reload.
Debugging, temporarily add.
Environment equals debug equals 1.
Or modify.
Exec start.
To enable verbose logging, then examine output via.
Journal.
How do you configure and optimize Linux for database servers?
Database workloads demand careful tuning of kernel, memory, storage, and process settings. Kernel parameters.
/etc/sysctl-conf. VM swappiness equals 10.
Minimize swapping, critical for DB performance.
VM dirty ratio equals 15.
And
VM dirty background ratio equals 5.
tune write-back flushing.
FS file max equals 2,097,152.
Allow high file descriptor counts.
Net core SOMXCON equals 65,535.
Handle large connection backlogs, memory. Allocate 70 to 80% of RIM to the database buffer pool in no DB buffer pool, PostgreSQL shared buffers. Configure huge pages for databases that support them, PostgreSQL, Oracle. To reduce TLB misses, leave enough free memory for the OS page cache and other processes, storage. Use XFS, preferred for database workloads due to scalability and parallel I/O, mount with.
No time, not at time.
To eliminate unnecessary metadata writes, use I/O scheduler.
MQ deadline.
For SSD to CAS or
BFQ.
for HDDs, RIID10 for the best combination of performance and redundancy. Separate volumes for data, WIL/logs, and temp to reduce I/O contention, process, and CPU. Increase limits in
/etc/security/limits-conf. NA file.
open files,
nproc.
processes, set CPU governor to.
Performance.
For consistent latency, on NUMI systems, use.
Numactal.
To ensure the database allocates memory from local nodes. Monitoring, use Prometheus with database-specific exporters, Postgres exporter, Miscled exporter. For query performance, connection counts, and buffer hit ratios.
How do you implement and maintain LVM, logical volume management?
LVM provides flexible disk management through a three-tier hierarchy: PVs, VGs, LVs, initial setup.
Code PV create /dev /sdb /dev /sdc, VG create dative /dev /sdb /dev /sdc, LV create L100G end dative dative, MKFSXFS /dev /dative /dative, mount /dev /dative /dative /data.
Growing storage.
Code #add a new disk to the VG, PV create /dev /sdd, VGextend dative /dev /sdd, #extend the LV and resize the file system, lvextend L plus 50G /dev /dative /dative. XFS growth /data #XFS online, or resize 2fs /dev /dative /dative #ext4 online.
Snapshots for backups or testing.
Code LV create L5G SN data snap /dev /dative /dative, mount O row /dev /dative /data snap /mnt /snapshot.
Live migration. Replace disk without downtime.
Code PV move /dev /sdb /dev /sdd, vgreduce dative /dev /sdb, pv remove /dev /sdb.
Monitoring.
PVS,
Slash.
VGS, LVS,
Compact status display.
PV display, VG display, LV display,
Detailed information. Backup LVM metadata.
VGCFG backup dative,
Thin provisioning.
LV create thin.
Allows overcommitting storage, but requires careful monitoring to prevent actual space exhaustion.
What is Linux containers LXC, and how do they differ from Docker?
LXC, Linux containers, is a lightweight virtualization technology that runs isolated Linux systems sharing the host kernel. LXC vs Docker, design philosophy. LXC, system containers, runs a full OS within its system and multiple processes, behaving like a lightweight VM. Docker, application containers, optimized for single process, microservice-style workloads, runtime. LXC uses its own runtime directly leveraging kernel namespaces and cgroups. Docker originally used LXC, but now uses containered with its own image format and layered file system. Image management. Docker provides a layered image format, Dockerfile and registry system, Docker Hub. LXC uses OS templates or LXD image servers. No equivalent to Docker files management, LXC.
LXZ create, LXZ start, LXZ attach.
Modern LXD adds a REST API and improved UX, Docker.
Docker build, Docker run, Docker compose.
When to use each, LXC/LXD, when you need VM-like behavior with low overhead. Multi-process workloads, testing environments, or running legacy applications that expect a full OS. Docker, microservices, CI/CD pipelines, application portability, and when you need a rich ecosystem of pre-built images. Many organizations use both. LXC for infrastructure-level isolation and Docker for application deployment.
How do you implement and manage KVM virtualization?
KVM, kernel-based virtual machine, is Linux's built-in Type 1 hypervisor, turning the kernel into a hypervisor for running virtual machines. Prerequisites: verify hardware support.
grep e vmx svm /proc/cpu info.
Install.
apt install chemukvm libvirt daemon system virtinst.
Debian/Ubuntu, creating a VM.
Code virt install name VM1 memory 2048 vc+2 \, disk size equals 20 cdrom Ubuntu ISO \, OS variant Ubuntu 22.04.
Management tools.
Virsh,
CLI for VM lifecycle.
virsh list all. Virsh start shutdown destroy VM1. Virt manager.
GUI for desktop management, Cockpit with the machine's plugin, web-based management, Proxmox VE/overt, enterprise management platforms, storage backends. QCOW 2 supports snapshots and thin provisioning, most common. RAW Better I/O performance for database VMTKS, LVM-backed storage pools for production, networking. Default NIT network via libvirt for isolated VMTKS. Bridged networking for direct LIN access, Open vSwitch for SDN and advanced VLIN management, performance tuning. Use Vertio drivers for disk and network, near-native performance. Enable huge pages for memory-intensive VMTKS, CPU pinning for latency-sensitive workloads. NUMI-aware memory allocation on multi-socket systems.
How do you implement Linux kernel hardening?
Kernel hardening reduces the attack surface and mitigates exploitation of kernel vulnerabilities. Sysctl hardening.
/etc/sysctld/99 hardening conf.
LE.
Kernel randomize vspace equals 2.
Full ISLR, address space layout randomization.
Kernel kptr restrict equals 2.
Hide kernel pointers from all users.
Kernel dmask restrict equals 1.
Restrict dmask to root only.
fs protected symlinks equals 1.
And
fs protected hardlinks equals 1.
prevent symlink/hardlink attacks.
Kernel yama ptrace scope equals 2.
Restrict ptrace to root, prevents process debugging attacks.
Netip 4 confolrp filter equals 1.
Enable reverse path filtering, module security.
Kernel modules disabled equals 1.
Prevent loading new modules after boot, set via sysctl after boot. Enable module signing to only allow signed modules, blacklist unnecessary modules in.
/etc/mod_probe_d/.
Mandatory access control. Enable SE Linux or AppArmor in enforcing mode. Develop profiles/policies for all critical applications. Additional measures. Enable seccomp filtering to restrict available syscalls per process. Mount.
/prog.
And
/sys.
with restrictive options where possible, disable user namespaces if not needed.
Kernel unprivileged users clone equals 0.
Auditing and compliance. Enable.
Audit.
For syscall level auditing, implement file integrity monitoring, IIDE OSSEC. Use Linux or OpenSCAP to audit kernel security settings and track compliance. Keep the kernel updated with security patches from your distribution.
How do you troubleshoot Linux boot problems?
Boot troubleshooting follows the boot sequence: firmware, bootloader, kernel, initramps, systemd, services, 1, firmware/hardware stage, check power, RIM seating, disk connections. Listen for beep codes, check firmware, BIOS/UEFI, error messages, verify boot device order, 2, GRUB bootloader. Hold Shift BIOS or ESC UEFI. To access the GRUB menu, press E to edit kernel parameters, add.
NA mode set.
For graphics driver issues, add.
Single.
Or,
Systemd unit equals rescue target.
for single user mode, if GRUB is broken, boot from live USB, mount root file system, and reinstall GRUB. 3. Kernel initialization, from rescue.
Journoctal B-1.
To review previous boot logs, look for kernel panics, driver failures, or hardware initialization errors. Regenerate initramps.
Update initramps U.
Debian, or
Drawcode F.
RHEL. 4. Systemd initialization.
Systemd list units failed.
Identify failed services, check.
/etc/fstab.
A bad entry can halt boot use.
NA fail.
For non-critical mounts,
Systemd analyze blame.
identify slow starting services. 5. File system issues, Boot from live USB then.
fsek/dev/sdxn.
To repair file system corruption, check disk health.
smartdla/dev/sda.
Recovery approach. Boot from a live USB, mount the root file system
Growth.
into it and fix configuration or reinstall packages as needed. Always back up config files before modifying them.
How do you manage Linux kernel modules?
Kernel modules extend kernel functionality without recompilation or rebooting. Core commands.
lsmod.
List currently loaded modules.
Medinfo module name.
Show description, parameters, dependencies.
Modprobe module name.
Load a module with all dependencies.
Modprobe r module name.
Unload a module and unused dependencies.
insmod.
Slash.
rem mod.
Low-level load/unload without dependency resolution. Loading at boot. Add module name to.
/etc/modules.
Or a file in.
/etc/modules load d/.
Setting module parameters at load time.
Modprobe module name param equals value.
Permanently add.
Options module name param equals value.
In.
/etc/modprobe d/.
View current parameters.
cat/sys/module/module name/parameters/param.
Blacklisting, prevent loading.
Blacklist module name.
In.
/etc/modprobe d/blacklistconf.
Prevents auto-loading.
Install module name /bin/false.
Prevents even explicit loading, security considerations, set.
Kernel modules disabled equals 1.
After boot to lock module loading on hardened systems, enable kernel module signing if your distribution supports it. Regularly review.
lsmod.
Output for unexpected modules, debugging.
dmask tail.
Immediately after loading/unloading.
Modprobe show depends module name.
Display dependency chain.
How do you implement user authentication with LDAP?
LDAP, Lightweight Directory Access Protocol, provides centralized authentication and directory services for Linux environments. Server setup, open LDAP, install.
apt install slapped LDAP utils.
Configure domain structure, for example.
dc equals example, dc equals com.
Enable TLS/SSL for encrypted communication. Create organizational units for users and groups. Client configuration. Install.
apt install libnceldap libpamldap nscd.
Configure.
/etc/ldapconf.
With server URI, search base and bind credentials, update.
/etc//nswitchconf.
To include.
LDAP.
For password group and shadow, configure PIMIN.
/etc/pamd/.
To use LDAP authentication, test.
Getent password username.
And.
ID username.
Modern alternative, SSSD. SSSD, System Security Services daemon, is preferred over direct LDAP PIM/NSS modules. Provides caching, failover between servers and offline authentication, supports LDAP, Active Directory and free IPA, config.
/etc/SSSD/SSSDconf.
Security, enforce TLS for all LDAP traffic, use.
LDAPs//.
Or start TLS. Implement password policies on the server, complexity, expiration, lockout. Configure clients to fail closed if LDAP is unreachable. Higher-level solutions. Consider free IPA, integrates LDAP, Kerberos, DNS, and certificate management for a complete identity management platform.
How do you implement and manage DRBD, Distributed Replicated Block Device?
DRBD replicates block devices between servers over the network, creating a network RIID, 1 for high availability. Replication protocols. Protocol A asynchronous, best performance, risk of data loss on primary failure. Protocol B semi-synchronous, write confirmed when received by peer's network buffer. Protocol C fully synchronous, write confirmed after peer writes to disk, safest but slowest, setup, install.
apt install DRBD utils.
On both nodes, load the module.
Mod probe DRBD.
Create resource config in.
/etc/drbdd/resource-res.
Defining nodes, devices, and protocol. Initialization.
Code drbdatum create md myresource hash on both nodes. drbdatum up myresource hash on both nodes. drbdatum primary myresource force hash on the designated primary.
Monitor sync progress with
drbdatum status.
or
cat/proc/drbd.
after initial sync.
Code mkfsxt4/dev/drbd0 mount/dev/drbd0/data.
Integration with clustering. DRBD handles data replication only. Use pacemaker plus corasync for automated failover of services and IP addresses. Configure STONITH/fencing to handle split brain scenarios. Management, monitor.
drbdatum status.
Eh.
cat/proc/drbd.
Configure split brain detection and automatic recovery policies. Dedicate a separate network interface for replication traffic to avoid contention. Test failover regularly to verify the setup works under real failure conditions.
How do you configure and manage syslog in Linux?
Syslog is the traditional logging standard. Rsyslog is the most common implementation on modern Linux systems. Configuration
/etc/rsyslogconf.
and
/etc/rsyslogd/.
a format.
Facility priority destination.
Example:
Kern warning /var/log/kernlog.
kernel warnings to a specific file. Example:
*crit/var/log/critical log.
all critical messages, remote logging, UDP.
At log server 514.
TCP.
At log server 514.
TCP with TLS. Configure
Lemtop.
with
Stream driver.
settings for encrypted transport, structured logging. Use rsyslog templates to format messages as JSON for log aggregation tools. Configure rate limiting to prevent log flooding attacks. Log rotation.
/etc/logrotate/d/.
To
Code /var/log/myeplog weekly rotate 4 compress missingok node empty post rotate is system till reload rsyslog in script.
performance tuning. Use in-memory queues for high-volume logging. Configure appropriate buffer sizes. Use asynchronous processing for non-critical logs. Note: on systemd-based systems, journaled captures all logs by default. Rsyslog typically receives forwarded logs from journaled for persistent storage and remote shipping.
How do you configure and manage DNS server, BIND, in Linux?
BIND, Berkeley Internet Name Domain, is the most widely deployed DNS server software. Installation:
apt install bind 9.
Debian/Ubuntu, or
dnf install bind.
RHEL, main config,
/etc/bind/nameconf.
or
/etc/nameconf.
zone configuration, define zones,
Named conf local.
or the main config, create forward zone files containing SOI, NS, AIIII, MX, CNIME records. Create reverse zone files for PTR records. Set appropriate TTL values based on change frequency, security hardening, TSIG keys. authenticate zone transfers between primary and secondary servers. DNSSEC, sign zones to prevent DNS spoofing. Generate keys with.
DNSSEC keygen.
Sign zones with.
DNSSEC sign zone.
Publish DS records in the parent zone. Restrict zone transfers.
Allow transfer trusted servers.
Enable rate limiting to mitigate amplification attacks. Restrict recursion.
Allow recursion internal nets.
Recursive resolver features. Response policy zones, RPZ. For DNS-based filtering, forwarding for efficient resolution, caching tuning based on available memory, management.
RNDC reload.
Reload zones without restart.
RNDC flush.
Clear cache.
Named checkconf.
/
Named checkzone.
Validate configuration and zone files. Monitor query logs for anomalies and performance issues.
How do you implement and manage high availability clustering in Linux?
HI clustering eliminates single points of failure by automatically failing over services between nodes, core components, core async, cluster messaging, and membership layer. Pacemaker, Cluster Resource Manager, decides what runs where. Install.
apt install pacemaker core async.
Or
DNF install pacemaker core async.
cluster setup, configure node communication in.
/etc/core async conf.
UDP unicast or multicast, start services.
System till enable now core async pacemaker.
Define resources, services, virtual IPTKS, file systems, or anything that should be highly available. Set constraints, co-location, resources that must run together, ordering, startup sequence, and location preferences. Fencing, STONITH. Critical for preventing split brain. Fencing forcibly powers off a failed node to ensure it can't corrupt shared resources. Options, IPMI, ILO/IDRAC, PDU, hypervisor IPI, or SBD, storage-based death. Never run a production cluster without fencing, storage options. DRBD, replicated block devices between nodes, shared storage, SIN/NIS. With cluster file systems, GFS2, OCFS2. Database-specific replication, Galera, PostgreSQL streaming replication with Patroni. Monitoring.
PCS status.
Or
CRM mon.
cluster and resource state.
PCS resource show.
Resource configuration. Integrate with Prometheus/Nagios for alerting, maintenance.
PCS node standby node 1.
Gracefully drain a node for patching. Regularly simulate failures to verify failover works correctly. Document recovery procedures for scenarios where automatic failover isn't possible.
How do you implement and manage Linux Virtual Server, LVS, for load balancing?
LVS, Linux Virtual Server, is a kernel-level Layer 4 load balancer built on the IPVS module, offering extremely high throughput. Setup, install.
apt install ipsetum.
Or
DNF install ipsetum.
configure a virtual IP, VIP, that clients connect to, packet forwarding methods. DR, direct routing. Best performance. Real servers respond directly to clients, requires VIP config on real servers. NIT director rewrites addresses. Simpler setup, but director handles all traffic. IP, tunneling. Encapsulates packets, supports geographically distributed backends. Load balancing algorithms, round-robin, RR. Equal distribution, weighted round-robin, WRR. Accounts for different server capacities. Least connections, LC. Routes to server with fewest active connections, weighted least connections, WLC. Combines capacity weights with connection count, example configuration.
Code ipsetum at T10.0.0.1. 80 SWLC, ipsetum at T10.0.0.1. ADR 10.0.0.10, ADGW3, ipsettima T 10.0.0.1, ADR 10.0.0.11, ADGW2.
High availability with keep-alived provides VRRP for floating VIP between active/backup directors, built-in health checking of real servers. Synchronizes connection tables between directors for seamless failover, monitoring.
Ipsettim LN stats.
View connection and traffic statistics. Configure health checks to automatically remove failed backends from the pool.